In this video, we're going to take a look at the volume of pyramids and cones. So, pyramids and cones versus prisms and cylinders, which we previously learned. We remember that the volume for prisms and cylinders is the base area times the height. So let's figure out what the volume formula for pyramids and cones is. So let's try something here. How many of these square-based pyramids does it take to fill up that square-based prism? Let's assume that they have the same square as a base and the same height. It turns out it's the same formula for cones as it is for pyramids. Same idea. How many of these cones does it take to fill up that cylinder? They have the same circle as a base and they have the same height. So you want to play a guessing game? How many does it take? Does it take 2, 3, 4, 1.5, 2.5, 3.5? Make your guess. And we're going to start removing the wrong answers. Here we go. It is not 3.5, or 1.5, or 4, or 2. It is 3. It takes 3 of those pyramids to make the same volume as the square prism. It takes 3 of those cones to make the same volume as the cylinder. So you could take the volume of the cone and multiply it by 3 to get the volume of the cylinder. What if we go in the other direction? What if I have the volume of the prism, which we know is base area times height? What would I do to that to end up with the volume of the pyramid? I would multiply by 1/3, which is the same as dividing by 3. So this leads to our formula. So the formula for the volume of pyramids and cones is 1/3 the base area times the height. Let's go ahead and take a look at a problem. There's our formulas at the top. You can write it either way, 1/3 times base area times height, or base area times height divided by 3. So here's our first problem. We're going to calculate the volume of this pyramid. So our volume is going to be 1/3. The base of it is 8 by 8, and the height is 9. Now we just simplify this, and we're going to be left with our answer of 192. So what kind of units? Well, look at the markings on the diagram. What happens when we go centimeters times centimeters times centimeters? That would be centimeters cubed. Okay, let's try another one. Same formula. In this case, our base area is a triangle. So that'd be 1/2 times 8 times 6. Our height is 10. And this time, instead of writing the 1/3 at the start, I wrote divide by 3 on the end. And we simplify this down. We're left with 80 cubic inches. All right, what about our cone? It is technically the same formula, but cones always have circles for their base. So we can have a specific formula just for cones. It's 1/3 times pi r squared times the height. So for this problem, we would have 1/3 times pi times 7 squared times 18. And when we simplify that down, we get 294 pi. And they didn't give us units, so we would just call those units cubed. Before we move on to practice problems, let's take a look at what I think of as the curious case of the square-based pyramid. So oftentimes in these problems, you're going to be asked to find both the volume and the surface area. And with a square-based pyramid, they often don't give you every measurement that you need. You have to figure out the missing parts. So a curious part of this shape is, what is that highlighted line there? Is that a leg of a right triangle? Is it a hypotenuse of a right triangle? And is it the height of something? So let's examine this by splitting it into 2 parts here. So on the left, that green right triangle, that original highlighted dashed line, that's the leg of that right triangle. Now, over on the right, we can draw a different right triangle. Now that dashed line is the hypotenuse of a right triangle. And that's what makes this kind of the curious case, that dashed line is both the leg of a right triangle and the hypotenuse of a right triangle. For the one on the left, that is the height of the right triangle, whereas on the right side, one of the legs of the right triangle is the height of the pyramid. So we have two types of heights that we need to do volume and surface area. We will use the height of the pyramid for the volume, but we'll be using the height of the right triangle for the surface area. So let's try a problem. We're going to start by solving for some missing parts that we need. First thing that usually happens is, instead of giving you that bottom leg of the right triangle you can see, they give you the full side length, which is 10. That right angle is in the center of our square base. So we end up taking half of the 10 to get 5 for that bottom leg. Now we're going to go ahead and use Pythagorean theorem to solve for our missing side. So 5 squared plus 12 squared equals x squared, giving us 25 plus 144, which is 169, which is a perfect square. And the square root of 169 is 13, which I'm going to go ahead and label our diagram with, and then I'll erase so we got more space to deal with. All right, we now have everything we need for both volume and surface area. So my volume is the base area of 10 times 10 times the 12. Now, that's not right yet. That's a common mistake to stop right there. Do you know what I need to add for pyramids? We got to add in the divide by 3, or you could have put 1/3 at the beginning. We simplify this down, and we get 400 cubic meters. Now for our surface area, remember, we want to go ahead and show kind of a diagram of all the faces we have. So we have a 10 by 10 square on the bottom, and then we have 4 triangles who have a base of 10 and a height of 13. And we go ahead and write our formulas, 10 times 10 for the square, and then the 1/2 times 10 times 13 for the triangle. Simplify these down, and our final answer is 360 square meters. Let's look at another situation with the curious case of the square-based pyramid, where this time they're not giving us the height of the pyramid, they're giving us what's called the slant height of 10 centimeters. So once again, we're going to solve for this right triangle that exists in the middle of our shape. So the 10 in this case is a hypotenuse, and then we divide the 12 by 2 to get 6 for that lower leg, and we'll solve for the other leg. So we have x squared plus 6 squared equals 10 squared, and that gives us x squared plus 36 equals 100. Subtract, and we get x squared equals 64, another perfect square, so x is 8. So I'll mark our diagram and erase to make some space. Volume is 1/3 times the base of 12 times 12 times the height of 8. We need the height of the pyramid, not the height of the right triangle on the face. That leads us to 384. And let's do our surface area. Surface area, we're going to draw our diagram, a 12 by 12 square plus 4 triangles with bases of 12 and heights of 10. Our formulas are going to be 12 times 12 for the square and 1/2 times 12 times 10 for the triangle. And we simplify this down, and we end up with 388 centimeters squared. Now this is exactly what I wrote out when I made this slide. When I solved for my surface area, I realized I made a mistake somewhere. Do you see where? The more you think about what units you use, the better chance of catching your mistakes. So once I realized, hey, this is centimeters squared, hold on, I messed up my volume. My volume is not centimeters squared, let's fix that. That should be centimeters cubed. Time for practice problems. So when you see the problem, go ahead and pause the video And here's your first one. So our answer here is the volume is equal to our base area of 8 times 8 times the height of 9 divided by 3. And that simplifies to 192 cubic centimeters. Go ahead and pause the video and give this next problem a try. So in this one, we're going to have the volume is 1/3 times a base, which is a rectangle, which is going to be 10 by 8, and the height of the pyramid is 6. When we simplify, we get 160 cubic inches. Okay, next problem, find the volume of this cone. So our setup this time is 1/3 times pi times 10 squared times the height of 25. That leaves us with 2,500 pi over 3 cubic centimeters. Now, since we have a fraction here, you could leave it like that. That's the exact answer. But this is a time where maybe it's good to go ahead and put this in the calculator and get a decimal answer. Your final decimal answer is 2,617.994 cubic centimeters. Okay, last problem. This is our curious case of the square-based pyramid, and you're going to find both the volume and the surface area. Okay, this time I have everything I need to find the volume, so I'll go ahead and find that first. So that's going to be 1/3 times the base of 60 times 60 times the height of 40. And that simplifies to 48,000 cubic feet. Now for surface area, I got to find the height of my triangle. So there's that right triangle I'm going to be working with. And I take my 60 feet and divide by 2 to give me 30 on the bottom. And so Pythagorean theorem would be 30 squared plus 40 squared equals x squared. You can solve this out, but I'm noticing a pattern here. This is just a 3, 4, 5 triangle that's been multiplied by 10. So I know that the hypotenuse there is going to be 50. And that hypotenuse is going to be the height of the triangle, the isosceles triangle for our 4 faces. So I'll go ahead and write my diagrams. I have a 60 by 60 square, and then I have 4 triangles that have a base of 60 and a height of 50. The formulas will be 60 times 60 and 1/2 times 60 times 50 for the triangle. And when we simplify this down, we get 9,600 square feet. That's it.